Raoult's law states that the vapor pressure of a solvent decreases when you add a non-volatile solute. The relative lowering of vapor pressure of a dilute solution of non-volatile is equal to the mole fraction of solute in the solution. And we can basically write it as Pi equals to Pi star times mole fraction. And this is the mole fraction, by the way, which is important. And it changes between 1 and 0 since it is just a fraction. Pi star is equilibrium vapor pressure of the pure component I. And Pi is basically partial pressure of component I. If we want to find the total pressure, for instance, we have two different solvents or the solute and solvents. For instance, we have one solute here and we have a solvent here. And we want to show the total pressure. Basically, we can add the first one and its mole fraction plus the second one, and I will use the red color, and its molar fraction. And these are the equilibrium vapor pressure of the pure substances. Basically, we can find the total pressure. But the main thing we have to consider that Raoult's law is only valid for the ideal solutions. And there are not many ideal solutions. The reason is that there are so many requirements for the ideal solution. For instance, the first requirement is that all intermolecular interactions should be the same. And secondly, no volume change or heat change occurs when mixing, or delta H mixing should equal to be 0. So there is no volume change, by the way, and plus delta H mix should be equal to 0. And the other thing is that the solute does not contribute to the vapor pressure. And each component obeys Raoult's law across the full composition range. I know one ideal solution, and there are probably others, which is benzene plus toluene. I can write the molecular structures. So this is benzene, and this is the toluene. So they are very similar to each other. We have just a methyl group on toluene. So this is the only difference. And we can write the vapor pressure of this binary solution. I want to show it on a graph. So we have a graph here. I need a little bit space. For instance, we have a pressure of the toluene here. So this is the pressure of toluene when the toluene mole fraction is equal to 1. And we started to add, for instance, benzene. And benzene vapor pressure is higher, by the way. We have a benzene here, and this is the pressure of the benzene when the mole fraction of the benzene is equal to 1. So we are mixing them, and when we mix them, total pressure, P total, maybe I should use another color. Maybe I can use yellow. So this is the P total. I want to write as P tot, and it is equals to toluene pressure plus pressure of the benzene. But in this point, what is the pressure of the toluene? Actually, toluene pressure decreases from here to here. And it becomes 0 when the toluene mole fraction is equal to 0. And by the way, this is 0 point, and toluene mole fraction is 0. This part shows the molar fraction of the components, and these are the pressures. And I want to use the yellow color for the benzene. As I said, benzene equilibrium vapor pressure is higher, as you see, and it will start to decrease when it mixes with toluene. This is the partial pressure of the benzene, Pb, and this is the Pt, the red one is Pt. When we start to mix the components, their partial pressures start to change, and we can calculate it basically. For instance, consider a mixture. We have toluene and we have benzene. Let's say we have 3 mole of toluene and we have 1 mole of benzene. So what is the pressure of these two components at 25 Celsius? So temperature should be constant, since temperature directly affects the vapor pressure. By the way, vapor pressure of benzene and toluene should be known, and for benzene it is 95.1 torr, and for toluene it is 28.4 torr. I want to calculate the total pressure, for instance. So we are something like here. This is the mole fraction part. I have to find the point in here. How can I find it? So basically I will use the mole fraction of the, by the way, this is total, mole fraction of the toluene plus its equilibrium pressure at this temperature, which is 25 Celsius, plus mole fraction of the benzene times pressure of the benzene at its equilibrium position. And we know the numbers basically, and I have to calculate the mole fraction of the toluene. We have 3 mole of it. It's the total mole, 1 mole plus 3 mole times toluene pressure, which is here, plus benzene mole fraction, which is the opposite, 1 mole plus 1 mole plus 3 mole, times pressure of the benzene, 95.1 torr. So unit is torr definitely, or we can write it in here. Moles will cancel each other. So this is 3.3 over 4 times 28.4 plus 1 over 4 times 95.1. So this part is contributed by the benzene, and this part was contributed by the toluene. I want to calculate these two numbers. 28.4 times 3 over 4. This is 21.3. 1 over 4 times 95.1. And it is equals to 23.775. And P tot will be equal to this number plus 21.3. 45.075 torr. By the way, we should include 2 units also here. Don't forget. And this is our answer. I hope this video was useful for you.